Hi, I'm Dr. Gohdes, Joel, and we're going to be, throughout the semester, Tyler and myself are going to be making these videos, and they're designed to help you gain the best experience in general chemistry.
So welcome to Chem Review Post Class 1, is that right?
That's right. So today's class went pretty well, and we learned something about units and measurement, and then we moved into precision and accuracy and finished with significant figures. But there were a couple things that maybe I wanted to highlight. And the first thing that I wanted to talk about maybe was accuracy and precision. It seemed like I talked to one of my mathematician friends, and they use a completely different language to describe the same thing. And language is really important. So what do we mean by accuracy, and what do we mean by precision? So here we have a target, and we're going to throw beanbags at it to try to illustrate this.
So for our first test of accuracy and precision, Dr. Gohdes is going to be trying his best to hit this bullseye here, and I'll be marking exactly where his beanbags hit on the bullseye. So let's see it, Dr. Gohdes.
Go for it. So as you can see, I wasn't very precise. I have things scattered kind of all over the place, and I also wasn't very accurate because if you look at where these are clustered, they're not on the bullseye, right? So I wasn't very good. But guess what? I was throwing right-handed, and I'm actually left-handed. So I'm going to try it left-handed. What can I say? So, as you can see, way less accuracy because they're farther from the target. But it's actually a little bit more precise because the places I hit are closer together. They're clustered more tightly. So this is test 3, and Tyler's going to throw, and I'm going to mark his with the blue. Holy cow! Obviously, high accuracy, high precision. Because right on target, and they're all really close together. So this is test 4, and we're going to see how Tyler does with his left hand, because I don't think so. So to recap, in the first trial, I had a lot of scatter, but it wasn't on target. In my second trial, left-handed, they were clustered together, but they were really far off target. And so that's good precision, low accuracy. This is poor on both. And then Tyler, high precision because they're all close together, high accuracy because they hit the bullseye. And then his fourth attempt, we won't even talk about what happened there.
It was just too great.
So one place that you're going to see precision and accuracy is when you use balances in the laboratory. So in our lab, we use digital balances, and you put something on the balance, it reads the mass, and you just write down the number. And our balances read out to the milligram. And so you might see a reading something like this. And when you measure it, this number might fluctuate. It might go up to 3.002, and it might go down to 2.999. Right? So it's fluctuating in that last decimal, and that gives you kind of the precision of the balance. It's measuring to within 3 milligrams. Unfortunately, we don't know what the accuracy is. And so every year, before our students come to campus, we get a technician to calibrate the instrument. So the second part of the activity was about significant figures, and it seemed like people did pretty well on determining whether zeros are significant or not, but I thought we should probably just review it anyway. And so I've written down 4 numbers here, and so Tyler, can you tell me how many significant figures there are in each of these numbers? Well, he did well on this one because zeros in between digits are significant. So 1, 2, 3, 4. On this one, he did well because, again, zeros between digits are significant, but zeros at the beginning of a number never are. So these 2 zeros are not significant. Not so good on this one, but he did well on this one. And the reason is that there are different rules for trailing zeros. These zeros that are trailing, if they're trailing after the decimal, i.e. this one is on the right-hand side of the decimal and it's also trailing, that's significant. But this is on the left of the decimal, and it's trailing, and so it's not significant, right? And that's a common place where people get confused about significant zeros. So Tyler, the hard part about significant figures is when you start doing math with them, adding, subtracting, multiplying, dividing, or combining those operations. And so I want to go through just a couple quick examples of adding, subtracting, and then multiplying. So here we have three different examples. And 31.51 plus 1.501, we add those together. And the first step is just to do the math. Just add them together, see what your calculator spits out. So how do we decide how many significant figures are in the answer? Well, here we have 4, here we have 4. Should I use 4 for the answer? What do you think?
I'm thinking no.
No, exactly. Well, not necessarily. I don't know. We decide by looking at which number goes to the farthest precision. Right? This is precise to the tens place. This is precise to the thousands. Well, you don't know what this is up here, so we can't write an answer with something in the thousands. So wherever there's a question, that becomes not part of the answer. You round off. This is a question, and so we round off to that. So 4 significant figures, 2 significant figures, but the answer should only have 3. How about that last example? So 0, 3, 3. It's all nice. 3 significant figures, 2, but our answer should have 3. So subtraction is exactly the same rules as addition, but we thought that we would show you one example. These are matched up, so there's no question there, and so we keep all of the digits, so our answer has 4 significant digits. So multiplying and dividing using significant figures has different rules, but they're actually a lot simpler. So here we have 31.5 times 1.1, our answer 34.65. What do you think? How many significant figures in the answer?
That looks like a little bit too much, Dr. Gohdes. I don't know, you got 4 going on here, and we only have 3 and 2 up here.
Yeah, and so it turns out that the answer should have the number of significant figures as the least one that you're using in the problem. So we only have 2 here, and so our answer should only have 2. And so we should round this off to 35, 2 significant figures, and I have to round up because this was 0.6. Dividing is exactly the same thing. We have 3 significant figures, 2 significant figures. You use the number of significant figures in the smallest. So only 2 significant figures, and so we round that. So what do we get?
I'd say we get 29, since we'd have to round that up.
Yep, exactly. So that's pretty easy.
All right.
What about combining now? So when you're combining multiplication and division and addition, subtraction, you have to pay attention to order of operations. And you have to apply significant figures to each step individually and keep track along the way. And so for this problem, I did the problem on my calculator. I subtracted these 2 in parentheses, got the answer for that, and then multiplied it by this. And that's what popped up on my calculator. But I know that that's way too many significant figures. And so we have to first find significant figures for the answer for this part in the parentheses. And so we have subtraction, so how do we decide?
Well, when we're doing subtraction, right, we want to match up the decimal points. And since this one only has 1 number on the right side of the decimal point, we can only keep 1 number on the right side of the decimal point in the answer.
That question mark means that that's not significant. So we have 3 significant digits there. And now we can multiply 3 and 4. So how many should our answer have?
I'm going to go with 3.
That sounds good. Yep. And so we're going to round off to the tens place here. It's a 7, so we're going to round that up to 83.6.